Algebra 1 students, hello from Malaysia. I'm here to teach you on, my new whiteboard about lesson 73. The problem I'm having is that my markers are falling apart. So I'm going to use red. Lesson 73 is a two-part lesson, and the first one is a very useful, handy trick that we will be using quite a bit over the next few years. Is that clear? It looks really unfocused to me. So, well, I'll persevere and hopefully it will work out. Okay, here are some examples. If we have expressions of two terms, we sometimes notice a pattern that we call the difference of two squares. I'm showing you some examples of this. They're also in the book. But if you notice this, there are three conditions that have to be met in order for this to be a difference, an expression that matches difference of two squares. In order for this qualification, in order to be a difference of two squares expression, the first term has to be a perfect square. This is x squared. It's x times x. It's a perfect square. 4p squared would be 2p times 2p. That's also a perfect square. M squared, m times m. So the first number, the first term in the expression has to be a perfect square, and also the second one has to be a perfect square. Y times y, 5 times 5, 4 times 4. Notice that it doesn't matter whether they're numbers or letters, as long as it's a perfect square, meaning that it's two things exactly times each other, then you're fine. And then the third qualification is that in all cases there has to be a minus sign in the middle. Okay? Not at the front, in the middle. You can rearrange it to put the sign in the middle if you need to, but it has to be a minus sign in the middle. All right? So if you've got this pattern going on in an expression, then you have a difference of two squares, and here's something to memorize. Anytime you have that perfect square of a squared minus b squared, you can always factor it as a plus b times a minus b. You don't have to think about it. You don't have to calculate anything. You just memorize this format and know that you can always simplify your expression, your difference of two squares, by using this format. Also, if you have this, you can go in that direction. So this is a very useful piece of information, and you're definitely going to want to memorize that. So let's me get a baby wipe out here and clean. Oh no, I better not use it on my whiteboard. It'll make it wet, and that will be bad. So I'll just use my fingers. So, erasing. I don't have an eraser, and I forgot to grab a Kleenex before I started, so I'll just make do. So, what do problems look like with this style? Super, super easy. Example 73.1. I'm on page 299. Ooh, we're almost to 300. It says factor minus 4 plus x squared. All right, now right away you're panicking because you see that here's a perfect square. Well, but wait, minus sign, that's not a perfect square. That's a perfect square, but there's not a minus sign in the middle. Ah, panic. Wait, all we have to do is rearrange it. X squared minus 4. In addition, order doesn't matter, right? So as long as we keep the minus sign with the 4, we're fine. Now we have a difference of two squares. That's x times x. 4 is 2 times 2. The minus sign is the middle, so we know that we can automatically factor this as x minus 2, x plus 2. And in this, just so you guys know, in the answer, I might have given you the formula with the plus sign over here. I don't remember already, and I just erased it. But you can put the minus or the plus in either binomial, just as long as you have one binomial that's plus and one binomial that's minus. You'll be fine. Okay? So that's all there is to these. I'll do one more, and then I'll let you guys do the harder ones. Erasing with my finger. Let's do 73.2. And that is 49m squared minus a squared. So we see, you can tell this is a perfect square because it's 7m times 7m, and this is a times a. So we've broken it down. We see the minus sign right where we want it. And so now it's a simple matter of writing 7m minus a times 7m plus a. So simple, so easy, so fun. The difference of two squares. We'll be using that a lot. So you guys pause me. Go ahead and do example 73.3 and 73.4, and then you can meet me back here for part B of this lesson. Okay, welcome back. I hope that the examples went well. I now want to talk about part B, which is a probability topic. We talked about that with the, the spinners and the dice and the marbles in the urn. And we're going to talk about a special topic, which is probability without replacement. So here's the way these problems go. We've got an urn. It's got 3 black marbles and 5 white marbles. So I'm going to draw a picture of it. Here's my urn, right? And it's got 3 black marbles, pretend those are black, and 5 white marbles. 1, 2, 3, 4, 5. All right? Work with me. A marble is drawn at random and replaced. Then a second marble is randomly drawn. Okay, so the first question is, what is the probability that both marbles are black? Okay, so for part A, we want to know what is the probability that both marbles are black. Well, this is exactly what we've done before because the marble is put back. So each time we've got 3 black marbles out of 8 marbles in all. So we know that the probability of drawing a black one the first time is 3 out of 8. And then if we put the black, we take it out, then we put it back in, and so we have the very same arrangement the second time. So that's also a probability of 3 out of 8. And then we multiply them. 3 times 3 is 9. 8 times 8 is 64. So 9 out of 64 is the probability of drawing 2 black marbles in a row if we put the black marble back. But now, let's mess with your heads a little bit. I'm going to erase that one. Now they say, what's the probability if the first marble is not replaced before the second marble is drawn? Okay? So, we're assuming that the first time we draw a black marble, it will be exactly the same as before. 3 black marbles out of 8 total marbles. But if we draw a black marble the first time and we don't replace it in the urn, then one of them would go away. Yeah? See? Now, the probability the second time is different because we no longer have 3 black marbles. We took one of them out. So the second time we go to choose, the probability is only 2 out of 8. Does that make sense? Oh, no, I'm sorry. No, that's 2 out of 7 because we don't have 8 marbles anymore, right? We have 2 black marbles. We still have the 5 white marbles. And so the probability of getting a black marble the second time is only 2 out of 7. We multiply just like before. And what I'm going to do is I'm going to cancel before I multiply. 4 and 1. My friend's phone just rang. 3 out of 28 is the probability of getting 2 black marbles in a row when we don't replace. Make sense? So you guys go ahead and try 73.6 and see if you can get it to work. It's the same scenario where you have marbles in an urn. Okay, that is lesson 73. I hope you could see it. My markers are a little fuzzy. I'm still working on my technique here. But you go ahead and do example 73.6 and let me know if you run into any problems. See you.